Hey Ramblers, this video covers chapter 6.3 in our textbook and deals with parallel lines and parallel planes. Now in the last video, in 6.2, we talked about what it meant for a line to be perpendicular to a plane. If it was perpendicular to the plane, it was perpendicular to every line in the plane that passed through its foot. And in order to show that a line was perpendicular to a plane, we simply had to show that it was perpendicular to at least two lines in the plane passing through its foot. Well, parallel lines and planes are similar in that they have many of the same properties that parallel lines have. So after watching this video, you should recognize or be able to define what two parallel planes are, what it means for a line to be parallel to a plane, and what skew lines are. And you should be ready to use these properties and these definitions in problems. So please pay careful attention. I hope this helps. Thanks for watching. There are really a lot of basic facts to understand about parallel lines and parallel planes, but it's important that you understand the concepts beneath these facts. I'm going to give you a lot of definitions here, really about 4, and I'm going to give you some real-world examples. And it's important that you understand how these examples really do exemplify the definition. So let's take a look at the first one, and that's going to be when a line is parallel to a plane. So line J is above plane M here. And you recognize, of course, that plane M is infinite. It's infinitely wide and it's infinitely deep. And all the while, line J is above plane M. So they're never going to intersect. This will always be above M. And so that is really simply the definition of lines when they're parallel to a plane. A line and a plane are parallel if they do not intersect. Now let's take an example of that in real life. We can see that this bridge is never going to intersect the plane of the water. So if you can imagine, this bridge is a line, and this other bridge here in the background is also a line. They are parallel to the water. These two bridges may not be parallel to each other. That's not important. They will never intersect the plane of the water. So this bridge and this bridge are parallel to the plane of the water. And that's an example of a line and a plane being parallel. Okay, let's take a look at what two parallel planes would look like. Well, we've seen pictures like this in the book. Plane N is underneath plane M. And so these two planes have a space between them and they don't intersect, which is what makes them parallel. So parallel planes have a very simple definition. Planes are parallel if they do not intersect. Remember, both M and N are infinitely wide and infinitely deep, and the space between them will always be there, so they'll never intersect. Let's take a look at what some parallel planes might look like in real life. The floors of a building, while not infinite, are an example of parallel planes. The second and third floor, while not infinite, are not going to intersect, nor will they intersect the fourth, fifth, or any of the other floors. So while these are just floors of a building, they're not really representing infinite planes. They are parallel to one another because the floors will never intersect. Okay, now let's take a look at what are called skew lines. Now skew lines are simply non-coplanar lines. So get that in your notes. Two lines are skew if they are non-coplanar. So P and Q are on different planes. Q is on plane M and P is on plane M. And they don't intersect because these planes are parallel. Now, we would not say P and Q are parallel to each other, because if they were, then P and Q would define a new plane, which would intersect both plane M and plane N. So P and Q do not intersect, but they're also not parallel. They're called skew lines. Let's take a look at an example of what skew lines might look like in real life. These intersecting highways are an example of skew lines. the overpass and the highway below it won't intersect. Even though they do cross each other, they do so on different planes. So we say that the two lines, or the two roads, could be considered examples of skew lines. Okay, well, all this brings up a theorem. And it's simply that if a plane intersects two parallel planes, then the lines of intersection are parallel. Get that in your notes. If a plane intersects two parallel planes, then the lines of intersection are parallel. Well, let's take a look at an example of that. In this drawing, plane M is above plane N, and there's another plane cutting down. And on those, the lines of intersection between the vertical plane and M is line P. And the line of intersection between the vertical plane and plane N is line Q. So, because M and N are parallel, P and Q, these two lines, will also be parallel. We would not say that P and Q are skew lines, because even though line Q is on plane N and line P is on plane M, both of them also occupy this vertical plane, which is intersecting both of our parallel planes. So that's an important theorem, and let's take a look at what some of that might look like in real life. This office building, each one of the floors is intersecting a glass wall. So all the floors, as we saw in our earlier example, are parallel planes. As they intersect this glass wall, the lines of intersection, these seams here, are all parallel lines, parallel horizontal lines. All right, now, there are several kind of properties of parallel lines and planes. And let's go through them one by one. These will also be something that, while it's important to have them in your notes, you don't need to memorize them as much as just to understand them. So let's take a look at number one. If two planes are perpendicular to the same line, then they are parallel to each other. Let's take a look at what that might look like. Plane L1 and plane L are both perpendicular to line AB. So the two planes are perpendicular to the same line, therefore we can know that plane L1 and plane L are parallel to each other. Let's take a look at the next one. If a line is perpendicular to one of two parallel planes, it is perpendicular to the other as well. Well, that's really just the converse of what we just looked at. If this line is perpendicular to plane L, and if you knew that plane L was parallel to plane L1, then you would know that the line was perpendicular to plane L1 also. Now think about it. Okay, let's go to the next one. If two planes are parallel to the same plane, they are parallel to each other. Well, this isn't so bad. This plane on top is parallel to the plane on the bottom. This plane in the middle is parallel to the plane on the bottom. So therefore, it's kind of like transitivity. We know that the plane in the middle is parallel to the plane on top. Makes sense. If the first floor of a building is parallel to the second floor, and the second floor is parallel to the third floor, then the first floor and the third floor can be proven to be parallel. All right? If two lines are perpendicular to the same plane, then they are parallel to each other. Best example of this is the World Trade Centers. World Trade Centers were two lines that were both perpendicular to the ground. That's why they stood up so straight. And as such, they were parallel to each other. Number 5 is just if a plane is perpendicular to one of two parallel lines, then it is perpendicular to the other. And why don't we just use the same example? The plane of the Earth is perpendicular to one of the World Trade Centers. Since the World Trade Centers were parallel, it will be perpendicular to the second as well. Okay, Ramblers, let's go through one tutorial and then we'll conclude the video. Thanks for watching. Number 7 on page 285 is a good example of the kind of proofs we need to do in this chapter to show that we understand some of the theorems we've come across. The first given tells us that E is parallel to F. So therefore, any plane intersecting E and F, the lines of intersection will be parallel. So let's write that down. Since we know that the intersecting lines RT and SV determine a plane, we know that RSP, or however you want to name it, is a plane. Therefore, we can say that RS is parallel to VT because the lines of intersection are parallel if a plane intersects two parallel planes. Since they give us that RS is congruent to VT, I know that RSVT is a parallelogram because it has one pair of opposite sides congruent and parallel. Therefore, it's a parallelogram. So, to conclude and show that RV is parallel to ST, that has to be true because if opposite sides of a parallelogram are congruent. So therefore, RV is congruent to ST. Okay, Ramblers, good luck with these. We're going to bring back a lot of some of the stuff that we learned in the first semester, and that's okay. It's a good review. But really, again, be sure that you're comfortable with the concepts that come up in this section. Okay, thanks for watching.